Thanks, Mairead, and good morning, everybody, and good morning to those online. I understand there's 220 people online at the moment, and we've got about 80 people in the audience, so a good cross-section, I think, of the building professionals in the country, and this event is recorded, so it will be available to other people to catch up with who can't attend at the moment. This presentation is in fulfilment of a duty assigned to the Department of Housing under the National Radon Control Strategy Group. So I'm very grateful to Mairead for having me put on today's event to get the message out, specifically dealing with radon in this instance. So my focus will be initially on radon, and I'd like to go through the requirements of the building regulations in relation to radon specifically, and then follow up with the other areas. So just to move on, the technical guidance document C, which is blue, it may not appear blue on your screen, hopefully in the slides it will be blue, has been updated twice in the last couple of years. In 2020, we introduced the requirement for a new specification for hardcore in the build-up underneath the floor to allow for greater extraction of radon in the event that there was a need to extract radon by depressurizing the subfloor void. And in 2023, we introduced the new radon map, which is a digital online interactive map that was produced by the EPA. So the current document is structured in three sections. The first section deals with site preparation and site drainage. The second on dangerous substances, and this is where radon and landfill gases come in. And landfill gases are possibly becoming more important as we build on more and more brownfield sites and on sites in areas that have been contaminated, and they can be contaminated simply by the burying of the dead carcasses of animals, for example, can release gases that are dangerous for humans to ingest and can build up in buildings. So landfill gases are something that we need to have a little bit more focus on. Thankfully, most of the issues around keeping radon out also keep those landfill gases out from the majority of residential buildings at least. And the third section deals with resistance to weather and ground moisture, and specifically floors next to the ground and external walls in keeping moisture from the ground out of external walls, and the keeping external moisture in rain and snow from entering the building through the walls. I'm not going to have much time to deal with the site preparation and the landfill gases today. I'll focus on the other areas of the guidance document. So let's deal with first what we will deal with is site preparation and site drainage, and just building regulation C1, which is the ground should be covered, to be covered by a building should be reasonably free from vegetable matter. And regulation C2, subsoil drainage shall be provided if necessary so as to prevent the passage of ground moisture to the interior of the building or damage to the fabric of the building. I don't intend to go beyond the requirement in this presentation, but I'd like to skip on now to section 2, which deals with dangerous substances, and specifically building regulation C3, which deals with radon as part of that. So the requirement is that reasonable precautions should be taken to avoid danger to health and safety caused by substances, including contaminants, found on or in the ground to be covered by a building. And in this part, contaminant includes any substance which could become flammable, explosive, corrosive, toxic, or radioactive, and any deposits of fecal or animal matter. So those are the contaminants that have to be looked for in the site investigation before you decide to even build on any given site. And an extensive site investigation is a requirement of the building regulations to ensure that you can adequately assess the risk of those contaminants being in the ground before you even begin to build. So it's no point trying to deal with it afterwards. You've got to investigate the site for these contaminants first and decide whether building on that site is even possible. Let me move on to 2.7, which is the national reference levels for radon in buildings, and they're divided into two parts, dwellings and other buildings. So the dwellings, the requirement is that we should have a radon exposure level of less than 200 becquerels per cubic meter. We can't design buildings for that. We can only design buildings and test them after they're occupied to see if they meet that or not. But we can do our best. And the provisions in the technical guidance document are about doing your best to ensure that you produce a building that has the best chance of getting to that level, and if it doesn't get to that level, of correcting it after the event without having to throw all the occupants out and rebuild the building or reinstall the floors. In terms of workplaces, they fall under different legislation, which is introduced by the EPA, and it sets a reference level of 300 becquerels for workplaces, and this needs to be regularly tested for. So every few years, every workplace in the country is going to be tested for radon, and that should have a big uplift in the number of buildings that are declared free or are below the threshold level for action, or if they're above the threshold level, they're remediated. So I think we're going to see over the next few years a great improvement in the average radon exposure level in the country, which is going to be welcome. 2.10 deals with dwellings or other long-stay residential buildings and what the recommendations of the technical guidance document are for prima facie compliance. It's divided into two areas: high radon areas, which are the areas that are in red on the new radon map. We've simplified the radon map. It used to have 5 different colors on it, and it was a bit confusing. It was also very imprecise. It was kind of hard to work out where you were. It's now specific to a given site, and it's clear that it's either a high radon area or another area. It's a high radon area, it comes in red. And you can have sites where the radon is indicated in a part of the site, but not another part of the site. It is that fine, the designation. In the event that a building, any part of a building, is included in a high radon area, the whole building is to be designed as if it were in a high radon area. So in terms of the measures to be taken to protect the building from radon in the ground, for example, in the case of non-complex buildings of normal design and construction, the following measures should be provided. First one is a fully sealed membrane of low permeability over the entire footprint of the building. And in the event that radon still gets into the building, a potential means of extracting radon from the substructure, such as a standby radon sump or sumps with connected pipework and other appropriate certified systems. Let me just catch up. I'm sorry, I need to catch up with the slides here. Okay, so high radon areas, the red areas, fully steel membrane, and a sump. Now, this is a standby radon sump. It doesn't do anything at all for radon. People see the radon cover in the pavement and they think, oh great, my house is protected against radon. Absolutely nothing to do with protecting the house from radon. The sump is provided as a remediation assistance in the event that you need to take measures to fix the building afterwards because of a high radon test result. For areas other than high radon areas, so this is dwellings or residential, long-stay residential buildings in areas other than high radon areas, these would be the white areas on the radon map. The building should be provided with a potential means of extracting radon from the substructure. So this is the sump provision. If that proves necessary after construction, for example, in the case of non-complex building of normal design and construction, the provision of a standby radon sump or sumps in connection with the connected pipework and other appropriate certified systems should be adequate. Now, just let me take a moment here to do a little bit of a sidestep. This is moving forward into section 3 of Technical Guidance Document C. And the reason I include it here is because there is another membrane that's involved, which applies to buildings that are in non-high radon areas, and that membrane is called the damp-proof membrane. And this should be laid beneath the concrete, and it should be at least 300 microns thick, 1200 gauge. It should be laid with all of the joints sealed, and it should be in accordance, the installation should be in accordance with Code of Practice 102. And it should be laid on a bed of blinding, which will ensure that no stones in the hard core puncture the membrane. So you can see that even a damp-proof course has to be installed in a particular way designed to assist with the exclusion or the prevention of the ingress of radon from the building. It's not only dealing with moisture, it's dealing with radon and ground gases. The requirement 3.1.4c is that the damp-proof membrane may be located above or below the concrete and should be continuous with the damp-proof course in the wall. And I'll come on to more detail around that later on as we go into section 3. But I'd like to bring your attention to Code of Practice 102, which dates all the way back to 1973. There are few enough people who were even born in this room were even born in 1973, let alone practicing architecture. So this is a very old document, but it's a good one. And we haven't found anything better, so that's why it's referred to in the technical guidance document. And under the continuity of membranes, 11.4, it has the following requirements and advice. It is essential that the damp-proof membrane in the floor should be continuous with the damp-proof course in the surrounding walls, and where necessary, a vertical damp-proof course should be incorporated to link the two, i.e. the damp-proof membrane in the walls and the damp-proof course in the wall and the damp-proof membrane in the floor. It's also essential that polythene sheet joints should be lapped by at least 150 millimeters and should be sealed with double-sided pressure-sensitive tape. I hope this is not news to anybody in this audience because it's been there since 1973. It was there before most of you were born, and I want to see it implemented because my understanding is it's not being implemented in reality. We're reading the first half of that sentence, which is overlapped by 150 mil, and then we're walking away. It needs to be sealed with double-sided pressure-sensitive tape. That's the requirement of CP 102. Punctures that might happen in site during the course of the work should be patched with polythene membrane of an identical thickness, lapped at least 150 mil, and also sealed with double-sided pressure-sensitive tape. Now, the provisions for buildings other than dwellings, the advice is that the designer should consider the provision of measures to protect buildings against high radon concentrations. In the absence of specific guidance dealing with particular buildings, the provisions of the guidance in 2.10 should be applied to those buildings as well. Let me go on now and deal with Technical Guidance Document D and its role in ensuring that the membranes in particular are fit for purpose. The requirement of Regulation D3 is for proper materials to be used. And what are proper materials? These are materials which are fit for the purpose, for the use in which they are intended, and for the conditions in which they are to be used, and includes materials which A, bear a CE marking in accordance with the provisions of the Construction Products Regulation, B, comply with an appropriate harmonised standard or European technical assessment in accordance with the provisions of Construction Products Regulations, or C, comply with an appropriate Irish standard or Irish Agreement certificate, or with an alternative national technical specification of any state which is a contracting party to the agreement of the European Economic Area, which provides in use an equivalent level of safety and suitability. So it's not just good enough for your foreign certificate to be provided to the Building Control Authority as prima facie guidance. It needs to be shown to be offering the same equivalent level of safety and suitability as would be provided by an Irish agreement document. Just in relation to membranes, membranes may be used for radon protection and should be appropriate to this use. And the kind of things we're looking for are that the fitness is established by an independent certification by an approved body, for example, NSAI Agreement. The parameters certified should include those in Table 3 of Technical Guidance Document C. And this is where those foreign certificates fall down, because they don't make any reference to Table 3 in Technical Guidance Document C. The minimum performance levels are set out for low-density polyethylene membranes, LDPE membranes, known to everybody as polythene. And an equivalent performance to LDPE can be used. So there are many different membranes that are on the market that are of equivalent performance to LDPE that can be used as a radon membrane. But we need some test evidence to show that it does comply. At the moment, there are about 600 different membranes that are approved for use in different parts of the world, mostly tested in the Czech Republic, which is leading the way in terms of this. Our requirement is Table 3 is so if you're reading an Agreement cert, you need to see that it does have a reference to Table 3 and specifically a reference to radon permeability. And the requirement here is that it be tested in a laboratory. Unfortunately, there isn't an EN standard for this or an internationally agreed standard for the test. So the test is carried out in a laboratory with radon gas, RN222, and it must achieve the level shown, which is 12 by 10 to the minus 12 meters squared per second. This is an extremely low figure, but LDP membranes do provide for that. Standard membranes also provide for that, and if they're tested, they can be used and they become known as dual-use membranes. So damp-proof membranes that are of a dual use as a radon membrane. They must be tested in accordance with this requirement and meet at this maximum radon permeability level. The other parts of this table are really harmonized standards and EN standards that really relate to damp-proof membranes, which are well covered by EN standards. And this is just some of the kind of NSAI Agreement certificates that exist for all of these membranes. So there are loads of them on the market, take your pick, but read the fine print. Some of them are liquid applied and need to be applied to a particular thickness standard. Now, they can be useful in retrofitting existing buildings, but you've got to be very careful to read the fine print to say what you need to do and how you need to write your specification to get a membrane that satisfies the requirements of Table 3. Let me just summarize then what the measures are in Technical Guidance Document C in relation to radon. And I'm going to pause on this after we go through it and explain how they interact. The first one is obviously the standby sump. That's universal. It's provided in every single building, regardless of its use and regardless of where it's located in the country. The standby sump is a kind of a backstop that we must not go below in any building. And this facilitates radon remediation. So if you get a bad test result, you now have a way to easily remediate the building and solve your problem without having to dig up floors or any of that kind of stuff. The reason the sump is there is to facilitate remediation. It applies in high radon areas and it applies in all other areas as well. The next one is a sealed membrane, which resists the entry of radon. And that's required in high radon areas only. And the second provision in terms of membranes is for a sealed membrane, a damp-proof membrane, which also resists the entry of radon. And that is required in areas other than high radon areas. So we now have two measures, essentially, a sealed membrane and a sump. And the reason we have both conditions is not accidental. They actually work together. If you activate a sump, you add a fan to a sump and start sucking radon out of the subfloor void, the fan will pull from the easiest source. If the ground is more resistant to releasing its radon than the house is to releasing its heat, it'll suck air out of the house. So the problem is that if there's no membrane between the sump and the house, it will suck air out of the house, and then the makeup air that's sucked into the house may come from the ground. So you can actually increase the radon intensity within the house by activating the sump if you don't have a membrane between the house and the ground. It stands to reason that the two act in tandem. You've got to have a membrane if you're going to activate the sump. So that's why the membrane, even though it's called a damp-proof membrane, has a role to play in ensuring that remediation is possible. And that's why the joints need to be sealed in the damp-proof membrane. Okay? So they work together. Other measures that have come in over in 2014, we introduced requirements for inspection and certification, SI 9 of 2014, which is commonly known as BCAR. And they introduced sign-off by a professional assigned certifier, a competent person, which brought independent oversight to the whole process of construction in Ireland, and it applies to high radon areas and it applies to other areas. And we produced this code of practice for the inspection and certifying of buildings and works as an accompaniment to the introduction of BCAR to identify what things need to be inspected. And there you go, lo and behold, table B2, stage 3A requires that the membrane is in place and intact. That has to be certified. That the standby sump and associated pipework is in place. That also has to be certified as present. And that requirement applies to high radon areas and all other areas. So we're seeing that there's universal provision in inspecting for the membrane and inspecting for the sump. There's another area that's included in that certification process, which is table B2, stage 5D, which ensures proper ventilation is provided within the building. This is ventilation to support the occupation of the building, not specifically ventilation of the subfloor void, but it's to ensure that pollutants that do get into the building are diluted by the ventilation system. And again, inspection is required for this in high radon areas and in all other radon areas. So these are universal provisions which assist, they're complementary provisions that assist in ensuring that the membrane is installed correctly and the sump is installed correctly and there is a proper system of ventilation in the new building. There are complementary measures in other parts of the building regulations that also have effect in relation to radon, but they're not specifically called out as such. So technical guidance document F, which deals with the ventilation of the building, introduced the notion of validated ventilation, and this dilutes the radon concentration within the building. So anything that gets by the membrane is inside the building. We now have a way of getting rid of it through the ventilation system. And that also applies to both high radon areas and all other areas. So that's a universal provision. Technical guidance document L, believe it or not, also has effect in relation to radon, because it introduced the concept of improved air tightness. And Ireland is now building very airtight buildings. As a rule, people are getting 1.5, 2 cubic meters per meter squared of envelope air tightness results, which are very high by international standards, certainly much higher than anything in the UK and many countries in Europe. And that provision applies to high radon areas, and it also applies to all other areas. The importance of this is that it reduces the radon entry pathways, because if there is a gap in the floor, the blower door test will find it and will appear on the test result for the air tightness test, and it will be sealed up. So this is a complementary measure. It's not specifically aimed at radon, but it has an effect on radon. And the sealing of service penetrations, and I point to this specifically because the radon entry pathways are very often alongside the pipework for the incoming water main or the heat pump connection or the sewer pipework in the floor. These must all be sealed as part of meeting technical guidance L recommendation. And again, it's a universal measure that applies in all radon areas. So we need to see top hats being used to make the seal between the pipe and the radon membrane, or between the cable grommet and the radon membrane, or the damp-proof membrane, so that we're ensuring that there is a proper seal around these service penetrations. And the issue on diluting radon concentration comes from the World Health Organization Radon Handbook for remediating membrane, and it says that occupied spaces will deliver, that ventilation, active ventilation of occupied spaces will deliver radon reduction of between 30 and 70%, which actually is what's expected of a radon membrane. So ventilation of the space is as good as a radon membrane according to the World Health Organization and research on the effectiveness of radon membranes. So if I could just go through and summarize what I've been saying about the universal provisions. So these are the total membranes, the standby sump, the sealed membranes, and where they apply. This is the test in table C test that you must check is provided for in the Agremont cert. And even if you've done all of that, and it is a lot of work to do to a building, there's no guarantee that you'll be successful. The highest radon area house tested in Ireland is over 10,000 becquerels per cubic meters, and it was found in a low radon area. So instances of geology and underground rivers and peculiarity of site will produce high radon areas, even high radon buildings, even in low radon areas. This is why it's important that we get this concept that it's holistic. We're trying to make sure that every building has adequate protection. The only way to know is to test. So we recommend that building owners have the radon concentration assessed. It's a very simple test, and I'll deal with that a little bit later on. And we deal with that through contacting the EPA, who have very, very good advice on how the radon concentration can be assessed. They also have very good videos on their website. This one deals with how to do a radon test in your own home, and it's aimed at householders. I'll give you a link to that later. And how to remediate in the event that you get a test that's above the reference level. And this is, again, a simple animated video explains the process of remediating a house. And they're all available on the radon.ie website, which is really the first port of call for all of this radon testing and advice around radon. And just to say that a radon test costs about €55, which is the same price as your NCT. Your NCT lasts 1 year, a radon test lasts 10 years. Not only that, but you're twice as likely to die in your house from radon as you are to die in a car crash because your tires are baldy. So the radon test is 20 times more effective than the car test. And nobody is testing their homes, and everybody is testing their car. So it's a really well spent €55 to send off for a test, stick the monitor up on your mantelpiece and in your bedroom, send it back to them 3 months later, and they'll post you out the results. You don't even have to apply for, if you've tried to get a car test recently, you don't have to go online and go on a queue and wait and go in the middle of the night to some place down an industrial estate. You simply order it online, it comes in the post, and you send it back in the post, and you get your result a couple of months later. So well worth testing for radon. That's all I'm going to say on radon. I'm going to move on now to resistance to weather and ground moisture. And this is really building regulation C4. Floors, walls and roofs of buildings should be so designed and constructed as to prevent the passage of moisture into the inside of the building or damage to the fabric of the building. In this part, floor includes any base or structure between the surface of the ground or the surface of any hardcore laid upon the ground and the upper surface of the floor, and includes floor finishes like fixed tiles, but it doesn't include loose furnishings or carpeting, that kind of stuff. Moisture includes water vapor and water in liquid form. It also includes water in frozen form because we do reference snow. So what do we mean by damage to the fabric of the building? This is damage so serious that it would produce a deterioration in the material or structure to the point that it would present a danger to health and safety. Okay? If it's insulating material, it's damage caused by moisture that impairs its performance permanently. Damage can be avoided either by preventing moisture from entering materials which will be damaged, or by using materials which are not susceptible to that damage. So in terms of floors, technical guidance document provides advice on 3 kinds of floors: ground supported floors, suspended timber floors, and suspended concrete ground floors. A ground supported floor should be constructed of dense concrete, laid on a hardcore bed, and incorporate a damp-proof membrane as follows. The concrete should be 150 mil thick. The hardcore should be 200 millimeters. Since people who haven't been listening recently may have missed that the increase of the hardcore bed has gone from 150 millimeters to 200 millimeters, and it's a different form of hardcore. It's called T2 Perm, which has no fines in it. This allows the sump to extract material, extract radon through the hardcore material without resistance. A damp-proof membrane, and I'll deal with that further on, and the hardcore should be placed in accordance with diagram D4, which is the next slide. So this was a new diagram that was introduced in 2020, just to include insulation. Previous to this, there hadn't been either enough insulation or the right arrangement and the right thicknesses of different layers. So we corrected that diagram. Essentially, the concrete that's required, the specification for the concrete here, it must be 150 millimeters thick, and that's a minimum requirement. It's to prevent cracking. And the a layer immediately below either the insulation layer or the concrete layer, which is the extraction layer, 200 thick T2 perm, is a no fines aggregate in which the sump sits. And this is to allow the sump to extract radon in the event that you need to activate the sump. And it also must have a damp-proof membrane, which can either be beneath the insulation on the left-hand side or above the concrete slab, depending on the type of foundation it is. In the one on the right is really most representative of a kind of a raft type foundation, where the membrane goes above the raft. And it must be connected to the membrane in the wall, as we've already seen. So suspended timber ground floor, this is a form of construction that kind of we haven't really been building in the last 20 years. We don't generally have glazed timber ground floors, but they are making a comeback now in the timber frame MMC world, because with modern methods of construction, it's necessary to bring whole capsules, floor capsules, to site and lay them down on the substructure. And this is reintroducing the notion of the raised timber floor, or indeed a raised steel floor is covered by the same requirement. So in this case, the ground should be covered by concrete at least 100 millimeters thick. And I won't go into, we're actually allowing for recycled hardcore below that, again, another 100 mil below that. So this is working out the depth of your excavation, as long as it's clean and free from vegetable matter or animal matter. And the concrete, the last line here, the concrete should be so laid that its top surface is not below the highest level of the surface of the ground or paving outside the building. This is so as not to produce a kind of a trough, a swimming pool under the building that could fill up with water in the event of flooding. So that's the deal, the reference to the hardcore and the oversight, what used to be in my school days called the oversight concrete. Now, there's also a requirement for a ventilated space, at least 75 mil between the top of that concrete and the underside of any wall plate that is obstructing the flow of air through this space. There's also a requirement for 150 mil between the top of that concrete and the underside of any floor joist or insulation in the floor. And the damp-proof course is on top of the tassel walls, supporting and isolating the timber elements from any dampness in the oversight concrete or the tassel walls. I missed one point there that I wanted to emphasize, which is that the ventilation of the subfloor void is really important. We have requirements here in Ireland, and they're laid out here. So it's 150 millimeters squared for each meter run of wall. So you need to work out your vent, free area of your vent, and make sure that you've got 150 millimeters squared per length, 1 meter length of external wall. And that will give you the size of vents that you need. And it's not just a case of putting an air brick in the front and the back. You need more than that. So it needs to be calculated and shown to comply with that requirement, because that's the definition of a well-ventilated space. And the reason we're insisting on this level of ventilation to the subfloor void is if radon is going to get into the building with this kind of floor, the only way of preventing it getting into the building proper is by blowing it out of the subfloor void before it even gets to the building. So we're insisting on this air movement under the floor, and it's to exhaust the radon before it can even consider getting into the building. Now, in relation to walls, let me deal with resistance to moisture on walls. Two sources of moisture, really: moisture coming up from the ground and moisture coming in from the rain, the wind, the snow, the atmosphere. So external walls and internal walls have to prevent moisture coming up from the floor. Even an internal wall is susceptible to rising damp coming up from the ground. And external walls just have to deal with the external environment, the rain, the wind, the snow, all the rest of it hitting the outside of the building. And the way the external walls are dealt with is two main ways of doing it, either using a cavity wall or using some kind of a cladding system. So the requirements for all walls, therefore, are A, to prevent moisture from the ground from reaching the inside of the building. So you'll see the moisture rising on the right-hand side of the diagram here. And the way we deal with that is using DPCs to interrupt the flow of moisture up the wall. Otherwise, it will come into the building. And to use a material that is not going to be damaged when it gets wet below the DPC. So there's no point putting a timber wall all the way down in the wet zone because it's not going to last. And it itself must not carry moisture into the building, so this is why we interrupt it with a damp-proof course. External walls, in addition to meeting A, B, C and above, have other requirements. So they should resist the penetration of rain or snow to the inside of the building, obviously enough. And this is the external environment, the wind, the rain, the driving rain on the outside of the building. They shouldn't be damaged by snow and ice. They should be able to stand up to that. There's no point in having a wall that's going to go spongy if it gets wet or freezes. And they shouldn't carry rain or snow to any part of the building that would be damaged. So they can't conduct rain or snow or moisture into the inside to meet a lining that is sensitive to moisture, like dry lining, a timber dry lining on the inside of the wall. That's precluded by this requirement. So in terms of cavity walls, may be constructed of two leaves or an outer leaf separated from the inner leaf by a drained, and it's really important that it's a drained air cavity. It's not just an air cavity. It's a really important function of the cavity that water will run down it regardless of how it gets in there, and it needs to be drained away at the bottom. Separated by an airspace and prevent the accumulation, accumulating in the cavity or being carried to the inner wall. And the external cavity may be built as follows: an outer leaf of masonry, bricks, blocks, stone, cast stone, depending on where you are in the country, and a cavity at least 50 millimeters wide. The cavity should be only bridged by wall ties attaching the outer leaf to the inner leaf, and have an inner leaf of masonry or framing with lining. So framing with lining means either steel frame or timber frame, as your inner leaf is acceptable in the construction of a cavity wall. We have updated all of the ACDs in 2021, and they take account of enhanced insulation levels to accord with NZEB and ZEB, the forthcoming standard for energy performance of buildings. And it's well worth having a look at the guidance document on acceptable construction details that's on the department's website. Now, I'm going to deal with external walls and roof in terms of cladding. And this is the last section, you'll be pleased to know. So external walls and roofs are dealt together with because slating and tiling is considered to be a form of cladding. And we'll see why that is as we go on through this. So the external walls and roofs should resist the penetration of snow and rain to the inside of the building, not be damaged by snow and rain, same provision as before, and not carry snow and rain to any other part of the building that would be damaged by it. Cladding can be designed to protect the building from rain or snow, often driven by the wind, either by holding the rain or snow at the surface of the building or by stopping it penetrating beyond the back of the cladding. And this has a diagram here. It's not a particularly brilliant diagram, but it does explain that we allow the rain and snow to be stopped on the face of the cladding or to get through the cladding and run down the inside of the cavity, the cladding, because the cladding is separated from the rest of the building by a ventilated void. So either it's jointless and has all its joints sealed and it's impervious to moisture, so the moisture will not enter the cladding, or it has overlapping dry joints, is impervious to weather, is impervious or weather resisting and is backed by material which will direct rain or snow that enters through the cladding back out to the outside face. Some materials can deteriorate rapidly without special care, and they should be only used as weather-resisting part of a building or roof if certain conditions are met. See Technical Guidance Document C. Now, I've seen instances where timber is now being used as a roofing material, and that falls under this, requirement. So it must be weather-resisting and not be damaged by being exposed in that way. Weather-resisting part of a wall or roof should not rely on paint or any coating. That includes a preservative treatment, which does not provide all of the weather resistance. Now, this is my last slide, and I'm just going to talk about the future changes of Technical Guidance Document C that are in the pipeline, and the kind of consultations that are going on at the moment. So SR 325 is under revision, and this goes back to your question, I think, about the full fill cavity, because the answer to your question is in SR 325. And Tipperary is a kind of like a borderline county. Some parts of Tipperary, some parts of Limerick, you can use a full fill cavity, other parts you can't. So we do get queries about why am I not allowed to fulfill my cavities? You want me to be more energy efficient? The answer is because you're in an exposed zone where if you've got an external leaf of brick, too much water is going to get through, and it'll get through the insulation and it'll start to wet the inside of your building if you fulfill. Question here at the back. It's a little bit too, sorry, for the benefit of people who are not able to hear you, the question was about balconies and balconies causing water to penetrate through the outer leaf and get on and damage and wet the inner leaf, because obviously the structural connection is inside the building. So it's a requirement of Technical Guidance Document C that doesn't happen. That's a basic function of a wall, to stop the flow of water from the outside to wet the inside. So that would be a failure of Technical Guidance Document C if you're allowing that to happen. How you do it, that's really your job. I'm not the designer of buildings, you are. And if you decide to put a balcony on, you've got to work out how to keep the rain out. Freestanding structures are possible. Just touching the outside of the building or connecting at parapet level and at ground level and just touching the rest of the building will avoid the issue completely, because it allows the cavity to run right the way through, and that's possibly the best solution. But I'm not offering you design advice. You're the designer. I only... Yes, it is an issue, and it does need to be designed out, because otherwise it's a compliance issue under Technical Guidance Document C. So SR 325 is under major revision and will take a little bit of time. As part of that, the masonry panel have initiated research into various wall types and their applications in different parts of the country, particularly taking account of the enhanced U values that we're now using generally under the NZEB regulation and will be using into the future under the ZEB regulation. So we've had to look at what's the impact of all of this insulation on all our standard wall types in various parts of the country. So that research is ongoing. There's also research into the application of renders and the necessity of renders in certain types of construction and the kinds of thicknesses of render. That's also being undertaken. And Construct Innovate are about to commence some research into modern methods of construction, and what I described earlier, the raised timber floor issue being dealt with, so that needs to be detailed correctly. So they're undertaking that work and research into defective concrete blocks, which you may have heard about in the news. We've also commissioned research from Med Éireann on a lot of climate-related weather issues. So we now are one of the few countries in the world where you can have a weather file for 2080 to test your building against, for all the different IPCC scenarios of how the climate is going to change. So you can choose whichever extreme or benign version of the UN panel on climate change you want to apply, and you can choose the year, the day, and the time, and you can tell what the weather is going to be like in Ireland out to 2080. Now, I wouldn't book your holidays on that basis, but it's certainly useful in predicting and modeling what the impact of climate change. So it's useful for overheating, it's useful for assessing how wet the walls are going to get and how long they're going to have to dry out, those kind of issues. And the driving rain index has been updated, and it will feed directly into the SR 325 revision, and from there into the technical guidance document C update. And then just the National Radon Control Strategy, any further updates there's a new version of the Radon Control Strategy coming out next year, and whatever it says will also be incorporated. So those are the ongoing areas of research. I'm afraid I can't give you a timescale for this. Some of this research kind of, you start off research and they say 2 years, and then at the end of 2 years they say, oh yes, but we need this, and oh yes, but we need this. So I'm not quite sure. I'm not going to be nailed down to a time for the completion of that. So that's me. Thank you very much. If you've got any queries, happy to accept them by email at buildingstandards@housing.gov.ie, and we do our best to issue a written reply to a written question. So thank you for your attention.